Okay, extending this as the newer part, determining the equation of an absolute value graph like this. Okay, so you should from grade 9 be able to determine the equation of a straight line. So if I gave you this one in isolation, that one in isolation, you should be able to. So we can immediately say we are able to determine the composite function. It's just going to be the equation of this line, the equation of this line. So the first one, 4, and it starts from x value of 2. So for x greater or equal to 2, this is my graph. Okay, now to determine what the graph is, I can go and look, extend it this way, and look at what its y-intercept would have been, and go from there, and say it's mx plus c, that's going to be my c value. If I'm not able to, if it's not given, like in this case, ignore my scratch there, what I can do is I can use my knowledge about the gradient, calculate the gradients. I have the point 3, 0, I have the point 2, negative 2. I can calculate a gradient and see that it's equal to 2. So I know it's already going to be 2x. You see it's a positive gradient of 2x. We just don't know what our c value is. Okay, we can substitute in points at the side. This isn't part of our main equation, but let's say I have our point there going through. I know it's 2x plus c. And I have a point here. So from grade 9, you should know substituting in any of these points. Let's substitute in 0 and 3. I can solve for my y value. And I see my y value is equal to 0 over there. Sorry, yeah, 3 over there. Good. Negative 6. Would it make sense for it to go through negative 6? It looks like it, yes. So I can solve for that. Again, that's grade 9. It's just using 2x plus c as mx plus c value. I calculated my gradients m. I could see this one, but you could calculate it from delta y over delta x if you needed a bit more time doing that. And then get there. Take some time, make sure you're able to do this. Okay, now the second one. Now I can see it exists to the left of 2, so it's 4x smaller than 2. Okay, and I can see it has a gradient. I already know if it's an absolute value graph, it's just going to have the exact same gradient but negative. But let's just look at it as well to see if it makes sense. For every 1 unit, I go to the right. So from 1 to 2, 1 unit to the right, I go 2 units down. So that makes it a negative 2x gradient. My c value is 2 because it cuts the y-axis at 2. So that is that. Okay, so if you're unsure of how to find the equation of a line, comment below this video. I can post videos on finding the equation of a line. There are a lot of them on YouTube as well. It is grade 9 work determining the equation of a straight line. So I was able to, by just looking at each of these, to write a composite function that's the equation of my graph. Okay, so I'm able to do that. Okay, what you're also able to see is that if you can see it's an absolute value graph and you're able to do that analysis trick, you can see it's a positive one. So I know y is going to be an absolute value graph with a positive thing in front. Okay, we're just going to leave it as positive 1. I can see my slope is 2, so I know it's going to be a 2x in here. I can see that it starts 2 to the right, so I know it's going to be a negative 2 in, whoops, sorry. Big mistake. Y is equal to, okay, don't make the mistake I did, 2x minus 2 like this. X moved 2 to the left, not 2x moved 2 to the left. X moved 2 to the left. The slope is 2 like this. And then what happened to my y? It starts from minus 2. You can see it's more difficult. I almost made a mistake there. But this would be an acceptable answer, or y is equal to 2x. And then it would be minus 4, minus 2 like this. Okay, and you can check that this answer would in fact give us this by looking at the composite function. Okay, again, this would be an acceptable answer. This would be an acceptable answer if I ask you to determine the equation. For a difficult question, I might ask you to determine this as like that last 5% of an exam. So make sure you can do these things for difficult questions. If I go and look at this, if I write it as a composite function, it would be positive whatever's in here, which would be 2x minus 4, minus 2, 4, when 2x minus 4 is in fact positive. And it would be minus what's in there, so minus 2x plus 4 minus 2 for whenever 2x minus 4 is in fact negative. So if I go and look at that, it would be, solving it, would be 2x minus 6, 4, and then this would be 2x greater than 2 dividing by 2x greater or equal to 2. And guess what? I got exactly this as this. So in fact, this answer is correct so far. Negative 2x, and then this would be plus 2. Guess what? That. And then 4x smaller than 2. So if you go and write this out, you'll get this. You should be able to go from this to that every single time. That's an essential part. To determine that this is this, you should be able to do. For a difficult question, you should be able to go to here. But we can spend a bit more time on looking at what changing variables in functions actually does to functions, like shifting up and down, shifting to the right for negative and left, and how you need to look at what happens to your x value, not what happens to a 2x value. So these types of things we'll look at more, but might give you a difficult question like this in an exam at some point.